Write a formula for the lateral surface area L and the total surface area T of each of the solids. So we have a rectangular prism, triangular prism, and a cylinder. Help us understand these formula. We're going to take a look at the nets that we looked at in some previous questions. So let me rewind the tape here. And remember on these three questions, 31, 32, and 33, we had the net, which is an unfolded three-dimensional solid, and then we were trying to find this, the total surface area. Total surface area just means finding the area of all of the pieces and adding them together. The lateral surface area is everything but the bases. I'll write that down real quick. Lateral surface area is equal to area of in our case, it's going to be rectangles. If it was a pyramid that we were going to do, it would be these triangles that are here around the side. Area of everything but the bases. Now, this word lateral, it means sides. So if you work out and you work your latissimus dorsi or your lats, they're the muscles that are right there on the sides of your chest. Let's see, I think there is a play or something in football. I'm not like a sports expert or anything, where instead of throwing the football down the field, you throw it to the left or to the right, which is called a lateral or something. Fact check that. Anyway, so what we're talking about on lateral surface area for this solid, if we fold this thing up, this should be a rectangular prism, which is the first one that we're doing. The lateral surface area is just going to be these four rectangles that are right here in the middle, and you would exclude the two bases right there. Okay, so if I wanted to find a formula for the lateral surface area, I'm just going to look at the fact that the lateral surface area basically makes a rectangle. And I need to find the length of the rectangle here, or the area of the rectangle, and I'd be done. The area of a rectangle, so let me make some sort of note here. It's a big rectangle. And specifically, this is only for prisms. Okay, we don't have to do the lateral surface area as far as a formula goes for pyramids yet, not until honors geometry. Okay, but for the purposes of this assignment, it's just the prisms. Okay, so area of a big rectangle, remember that its formula goes like this. A is equal to the length times the width. Right here is my length. Yoop, and then here's my width. Notice that the width here corresponds to the height of our prism. It's the distance between our two bases right here. So this width is the same thing as the height of our prism. Okay, now as far as the length of this thing goes, we'll look where it came from. Let me color coordinate this for you. Obviously, this piece here corresponds to just one side of my little rectangle, the base of it. This piece here is going to correspond to that one. Another color here. This one is going to wrap around right here. And then finally, this piece here is going to wrap around here. So notice that the length of our lateral surface is just the perimeter of this base right here, which is the reason why the perimeter comes up, a big P for perimeter comes up in our formula. So the area of this big rectangle, instead of saying length times width, it's going to be a big P for perimeter times the height. So let's go back down to our little formulas down here. Our lateral surface area is going to be P times our H. And I'm going to make a little note here that the P stands for perimeter. Perimeter, first of all, specifically of the base. There we go. So in this case, of course, the base being the purple rectangle that's right there. Okay. Now for the total surface area, what we did is we basically found all of the rectangles that surround the base. So the only thing that's left for the total surface area is to add in the two bases. And the two bases are going to be a length times a width in this case. All right, so to finish off this formula, we're going to start with the lateral surface area of perimeter times the height and add in our two bases. Our two bases, two of them, and then the area formula for one of these rectangles is a length times a width. Now, when we get into honors geometry, we're going to kind of generalize this. And instead of saying that this is a length times a width here, we're going to use a capital letter B for the area of the base. And the usefulness of this is that it doesn't work for just rectangular prisms, but you're going to see that it works also for triangular prisms. Let me quickly draw a net for triangular prism, and you're going to see that it is very, very similar to the rectangular prism one here. As a matter of fact, whenever I draw this thing, I'm just going to start with a rectangle for the lateral surface area. So if I was going to unwrap that thing, and then I'm going to put, let's say, a triangle on each one of these little sides here. Okay, and then this piece would come straight down, and then this basically corresponds to, it looks like the part that's just on one of these sides of the triangle, and then split this one as well. So you can see again that this corresponds with itself. This piece here would go along the hypotenuse, and then this one would go on this other leg that's right here. So again, you have the area of a rectangle for the lateral surface area. Area of the rectangle is going to be the perimeter of the base, which is going to be the length, multiplied times the height. Now, just so that it was not confusing, I put a capital letter H for the height of the prism here, which is the distance between the two triangles, and then a lowercase h for the height of the triangle, two different kinds of heights. But notice that the lateral surface area formula is still exactly the same. It's the perimeter of the base multiplied times the height, but we're going to use this capital letter H in this case, so it's not confused with that one. For the total surface area, we just need to add in our two bases that are right here. And remember that our base formula, one of these little guys, the area formula for that base is 1/2 base times height. But you're going to have two of them. If you multiply this 1/2 times 2, it cancels out, so you just have 1 BH. Okay, so that's what's going to be the total surface area. Start with the lateral, and then add in your two bases. But this is what I'm saying. I'm taking 2, multiplying it times the 1/2 BH. This would be your area of your base, like we were talking about, like right over here. But this 2 and this 1/2 essentially cancel each other out, right? And so you're just left with a BH. So if I was going to simplify that, it would look like just a B and a little h. And now that corresponds to 2 B's, 2 area bases. Now, believe it or not, the surface area formula for a cylinder is identical. It's just that you have different letters for stuff. So imagine this as a can, like say a can of beans or something like that, right? Where you have the top of your can and the bottom of your can. And you have this paper label that goes all the way around it. This paper label, you could cut it straight down between the two bases and then peel off that label, and that label would form a big rectangle, right? So it would look like this. You have this big rectangle, and then you essentially just have your two circles on the top and the bottom for your two bases. Now, as far as the lateral surface goes, right here, this big rectangle that's right in the middle, you want a length multiplied times the width. The width here, of course, is your height. And then the length, notice where it came from. It comes from wrapping around this circle. And what is the distance around a circle called? It is called the circumference. So this whole length here is the circumference. And as a formula, as we talked about in a previous video, that is 2 pi times your radius, where your radius is like right there. Okay, so usually we write the formula with a 2 pi r instead of a c, but it could be rewritten with a c. So your lateral surface area is going to be the length here, which is 2 pi r, multiplied times the height right there. So we have 2 pi r multiplied times your height, h. For your total surface area, the only thing that's missing are our two circular bases. And remember that one of those things is pi r squared. How many of them do you have? Well, you got 2 of them. So you just add that to your lateral surface area to get your total. 2 pi r h plus 2 pi r squared. Now, right underneath each one of these formula is a problem to practice it with. Okay, so on questions 41 through 43, use the formulae above. Solve each of the following problems. Some of them forward, some of them backwards. Okay, on number 41, the total surface area of a prism, so we're talking about this one here, is 320 meters squared. It is an area, even though this is a three-dimensional shape, it's an area, so it gets meters squared, not meters cubed. Find the value of x. Okay, so we have, it looks like a cube, but it's not, because you can see that this is 6 and this is 8. So all of the edges are not the same exact size. So what I'm going to recommend that you do, I'm going to steal this picture right here as a hint. Let's copy and let's paste. And instead of looking at like that, if you just kind of rotate it, you don't have to physically rotate it, you can rotate it in your head. The benefit of this is that if we use the 6 by 8 as the base, it makes it so much easier to solve because you're looking for just what this little height thing is. The x then becomes the height. So that makes it a lot easier to solve. So again, you're going to treat this edge here, the one that's kind of this dark shaded one, this side as the base, makes that problem so much easier to solve. On 42, find the total surface area of the solid. That solid, of course, is a triangular prism. So that the part that most people confuse on this one is they think it's a pyramid or something when it is definitely not. So what shape is the base here? Which helps you figure out like, oh, finding the perimeter, multiplying it times our height. The height in this case is the distance between the two triangles. Now, whenever you're going to find the perimeter of the base, there's a little piece missing. You have this leg, you have that leg. You'll have to do something in order to find the length of the hypotenuse here. And that little something was an 8th grade math teak, which of course is the Pythagorean theorem. So you'll need that information in order to find the perimeter of your base. 43, the base of a cylinder has a circumference of 34.6 inches. Find the lateral surface area of the cylinder given that its height is 11 inches. Now remember that this part here in this formula is the circumference of the base, right? Which is this big rectangle that you're trying to find the area of. The lateral surface area. It gives you your height. It wants you to find the circumference. You don't have to find the radius. You're just looking for the circumference. So another way to write that lateral surface area formula, remember lateral surface area, instead of writing 2 pi r, you can write big circumference, big C, multiplied times the height, and you're just solving this thing for C. And then that should finish off those problems.